Okay, today we're moving on to 8.3. We are going to graph the function ax squared plus bx plus c. We have added in that linear term with the b there in the middle. So when we take a look at this and break it down a little bit, we see that this a term still gives us, when the graph opens up or down, right? So when the graph is positive, it opens up. When the graph is negative, it opens down. Same thing, that hasn't changed. What is a little bit different is that our y-intercept is now c. So our y-intercept is not going to be on 0 anymore. It's going to be our c term. It's also not our vertex. So that's going to be a little bit different, and we'll talk about that later. So c is not always the vertex. And the last thing we have to do now is think about our x-coordinate of the vertex and our axis of symmetry. Well, our axis of symmetry here is always going to be our vertex because it's always going to go straight down the middle of that parabola. And it's going to be the lowest or the highest point on that parabola because once it hits that axis of symmetry, it's going to reflect around it and it's going to do the exact same thing. So it's either going to go all the way down, reflect and go back up again, or if it's a downward facing parabola, it's going to go up until it hits the axis of symmetry and then it's going to start going down again. So we're going to use the same formula for both of those, and that is negative b over 2a. That's going to, again, give us the x-coordinate of the vertex and that axis of symmetry. So let's take a look of kind of some of the other things that this is going to tell us. We have two new terms here. We're going to have a minimum value and a maximum value, and you're going to get those depending on whether that graph opens up or down. So as we said, this a is less than 0. That's just a fancy way of saying negative, and this a is greater than 0 is a fancy way of saying positive. But let's take a look. We have a maximum value when the function opens downward, or when that a value is negative. We have a minimum value when the a value is positive, or that parabola opens upward. And look at why. If it opens downward, we have a max value because there's nothing higher than that point right there. We can't have, if this is a 2, we can't have y equals 3 or anything else because it turns at that point and comes back and goes down. Same thing over here. So that sign in front, which we've talked about a lot, that positive or negative, tells us whether it opens up or down, and then that's going to tell us whether we have a maximum or a minimum. What we do need to figure out now is how to find our vertex. And our vertex is an ordered pair of x and y, and we have a way to find each of those. So our x is going to be our axis of symmetry, and we're going to use our formula of negative b over 2a. And our y value is going to be that maximum or minimum. And to find that y value, we're actually going to plug this x value we found back into our original function, and it's going to give us a y value, and we're going to come up with that vertex ordered pair. Let's take a look at some of those. So the first thing we're going to do is find the axis of symmetry and the vertex. So we know that our formula for axis of symmetry is x equals negative over 2a. We'll just write that there. And then for the vertex graph of the function, I'm actually going to put my little steps over here. For a, we're going to use x equals negative b over 2a. And then for the b part, we are going to use the axis of symmetry, which is our x value, and we're using that as our input. Oops, input. For this function, and we're just going to solve it. That's going to give us our y value, and that is going to give us an x and a y as our vertex. So the first thing we're going to do is label our A, B, and C. So we've got a positive 1, we have a negative 10, and we have a positive 2. So for our AOS, we have x equals negative b over 2a. We're going to substitute everything back in. X equals negative 10. Don't forget to carry that with it, over 2 times 1. And that will give us a negative 10 over 2. That's probably a step we could probably skip. I'm going to keep on going. That gives us a negative 5, which gives us a positive 5. Now, it's very important. Don't forget about just because you have 2 negatives here, because your A, B, or C, which your C is not going to help you right now. So we wrote it down, but we don't really have to. But any of these can be negative, and that's going to affect whether your axis of symmetry becomes negative or positive. So you have to remember to keep your negatives going all the way down, okay? So don't forget to carry them all the way down, and don't change any signs until you're finished. So our axis of symmetry is 5. And then if we look back over here, we're going to use the axis of symmetry x value as an input for the function and solve to get our y value. So for our vertex, so we'll just kind of make a little, this is axis of symmetry, and now I'm going to work on vertex. I'm going to go ahead and I'm going to put that x equals 5. And I'm going to put it back in my function. So equals 5 squared minus 10 times 5 plus 2. That's going to give us 25 minus 50 plus 2. And we combine all of that to get a negative 23. And we've said before that this f of x, that actually just tells us a y value. So our y value is a negative 23. So our vertex is 5, negative 23. I'm going to move on to number 3. And I'm going to do the same thing. I'm going to label A equals negative 2, B equals negative 8, and we're not going to worry about C. We can label C. We don't need it right now, but we're just going to not worry about it right now. So our axis of symmetry is x equals b over 2a. We will fill that in by substitution. We have a negative with a negative 8 over a 2 times a negative 2. All right, so going with our order of operations, we're going to keep this negative 8 on top for a minute, and 2 times a negative 2 is a negative 4. And now we have a negative 8 over a negative 4, which is going to give us a positive 2, but we still have this negative out front, so that makes our whole x value a negative 2. We take that negative 2 and we plug it in for the vertex. So f of negative 2 will give us negative 2 times 2 negative 2 squared minus 8 times negative 2 plus 5. And we're going to go with our order of operations. So we have a negative 2. That 2 squared will give us a 4. And I'm going to just write all this out. And I think I have mentioned to some of you that I take a lot of steps because I want to make sure that I'm not going to mess anything out. So I've done all of my exponents. Now I'm going to do all of my multiplication, which is going to give me negative 8 plus 16 plus 5, which is going to give me 13. And I know that makes my vertex, oh, you know what? I need to put parentheses around that there because that is an ordered pair. So that makes my vertex a negative 2, 13. So go ahead and pause it and work on 2 and 4, and then come back and move that out for just a second. You can take a look at the whole thing there. Go ahead and, after this, pause it. Go ahead and do 2 and 4 and come back and see if you got those right. Okay, welcome back. So for number 2, we found our AOS. Our A value is negative 4, our B value is 16. When we plug all of those in, that gives us an x equals 2. And when we plug that 2 into our function, that gives us a vertex of 2 and 16. For number 4, our A value is a negative 3, our B value is a 6. Plug all of those into our x equals negative b over 2a. That gives us an axis of symmetry of 1. Plug that 1 back in, and that gives us a vertex of 1, 4. So moving on to graphing, we pretty much have everything we need to find to be able to graph this. So I'm going to start labeling everything. I'm going to say A equals 3, B equals 6, and C equals 2. Now we're going to talk about why we need that 2, why we need that C value. So we didn't really need it for the axis of symmetry or the vertex, but we're definitely going to need it to be able to graph these functions. So first thing we're going to do is find that axis of symmetry. And we'll say the AOS. That's going to be x equals negative b over 2a. We'll just go ahead and write that every time so that it really gets ingrained in our brains, tattooed there. That's going to give us negative 3 over 2 times 6, which is going to give us negative 3 over 6. What did I do wrong here? I did that backwards, didn't I? 1 second. All right, go ahead and erase that, and let's plug those numbers in correctly. So we have our AOS. That is x equals negative b over 2a. That is going to give us negative 6 over 2 times 3, which will give us negative 6 over 6, which simplifies to a negative 1. So I'm going to go ahead and let's just put our x and y axes here, just right in the middle. Now this is my negative 1. I know that my axis of symmetry is right here on negative 1. So make that dashed line so you know that's where our parabola is going to reflect around that line right there. And let's find our vertex so we can plot that point. So our vertex we're going to plug that x equals -1 back into our function up here. So we have 3 times -1 squared plus 6 times -1 plus 2. That will give us a 3 times 1 plus a 6 times -1 plus 2, and do our multiplication. That gives us a -6 right there. And we know that means that we are subtracting, so that combines to give us a -1. So we have a -1 again. That is our y value. So our vertex is now -1, -1. So we can go ahead and we can plot that point right there. All right, so what do I do from here? Well, I know that that parabola is going to open up because my a value is positive. So I know the next thing I need to look for is something that is going to be a point up in this area, and we are lucky enough to have this c equals 2. And what this tells us is that if we were to put 0 in for our x's, that's going to give us 3 times 0 squared is 0, 6 times 0 is 0. That's going to give us a 2. So our y-intercept is going to be this 0, 2. So we can plot that right there, 1, 2. Now with a parabola, you always have a reflection around that axis of symmetry. So we know that we can actually plot a second point, or a third point in this case, because we already have our vertex. So we can see right here that this is reflecting 1 unit away. So we can just bring it right on over and have 1 unit right there. And we can connect those, and there we go. So that's got to be right because that is opening up just like it says. We've got our vertex at -1, -1, and we have those 2 points there. So it might be a little bit off, but for the most part, that is the general idea of that. Now domain. Well, our domain is all real numbers. Anytime you have a parabola, and you know what I forgot to do? I forgot to put these arrows here because that tells me that those lines go on forever and ever. And because of that, that means we can put any x value in that we want. We can put in the biggest x value you can think of, and it's still going to work. Even though we can't see it on this graph, it's still going to work because these lines go on forever. They just keep on going up. It just keeps getting bigger and bigger until any x value you can think of can be put in. But our range, which is our y values, we cannot have anything less than this -1 because our vertex tells us that. So our y value is greater than or equal to -1. So just by having this function here, we can actually get a lot of information from that. Let's do number 6 together. So we have a equals 2, b equals -8, and c equals -1. I'm going to find my axis of symmetry first because I have all of the numbers I need to plug into that formula right there. So we have x equals -8 over 2 times 2. Which is going to give us -8 over 4. And that will give us a -2, which means x equals 2. And again, we're going to come over here. Wow, sorry about that, guys. Let's see if I can find Mr. straight edge really quickly. And I can't, so, we'll just pretend like that was pretty and beautiful to start off with. How about that? It's like it's a dancing y-axis. I don't know. Okay, so we know that x is going to equal to, this is our axis of symmetry, so we're going to put that dashed line right here. I want you to do this every time, okay? You don't have to put it in a different color. You don't have to do anything other than make sure you put this here, and that way you see it every time, so you know where that line of reflection, that axis of symmetry, because that's going to help you plot those other 2 points. Okay, well, now we need to find our vertex. We've got a positive A. That tells me it's going to open up. So we're going to plug that x back in, which will give us 2 times 2 squared minus 8 times 2 minus 1. That's going to give us 2 times 4 minus 8 times 2 minus 1. That is an 8 minus a 16 minus 1, which will give us our y equals -9. That tells us that our vertex is 2, -9. So it looks like, obviously there's not 9 here, so I'm going to say these are by 2's, but these are 2, 4, 6, 8, 10. And that's a 1 and a 2. So yours is going to look like this, but next time maybe I should have done 2, 4, 6, 8, or put my x-axis a little higher. So we need a 2, -9. That's going to be right there. That is our vertex of 2, -9. Now we're going to go up here and look at our C. And that's going to cross the y-axis at -1. So that's going to be a 0, -1. So right about there. We know that we can take this, reflect it about the axis of symmetry. So we're 1, 2 units away. 1, 2, right there. And there's a sketch of our graph. So again, our domain is all real numbers, and our y value is going to be y is greater than or equal to, because again it opens up, it has to be everything larger, -9. Okay, so now we're going to look at whether the function has a minimum or a maximum value. If we go back to page 1 and we take a look at our notes, we know that a minimum value is when our a value is positive, and a maximum value is when our a value is negative, which is a little bit backwards. I feel like if you have a maximum, you have plus, you have more, you have the most. So we're going to go backwards. We're going to be opposite. We're going to have the inverse of that. So when you have a minimum value, it's going to be the lowest point on your graph. That means the graph has to be opening up upwards. The a value has to be positive. So for number 8, we have a negative out front. That's going to be a maximum value. So a is less than 0 means that we're going to have a max. To find that value, we're going to find that x value, because what we're doing, our minimum and maximum value is actually the vertex. It's going to be our y value of the vertex. So in order to find our vertex, we have to take our negative b over 2a. We're going to fill that in. I have a -5 over a 2 times a -1/2. Sorry, that got teeny tiny there. Which is going to equal still -5 on top. 2 times a -1/2 is going to be a -1. And -5 over -1 is a 5, but we have this negative out front, so we still have a -5. So our axis of symmetry, our x value of our vertex is -5. We're going to plug that back in to find our y value. -5 times, oh, sorry, -5 plus 2, and -5 squared is 25. We have a -5 times a -5, that's a plus 25 plus 2, and -1/2 of 25 is -12.5 plus 25 plus 2, which when combined together gives us a y equals 14.5. This means our max, because up here we said we have a max, our max is 14.5. Let's do number 10. So we know that we are going to have another maximum because we have a negative, and we need to find our x value first. So x equals -b/2a. That's going to be a -4 times 2 times -1. And again, that's going to give us, we're going to keep that negative out here, that's going to give us a -4 over a -1, which is a 4. Keep that negative, and I'm sorry, that's a -2. That's going to give us a -2, but we have a +2, but we have that negative out front, so we still have a -2. Plug that back into our formula. That's going to give us a -4 plus 8 minus 7. Y is going to equal a -3, so our max is a -3. Go ahead and finish the rest of these, give that max and min, and we're going to talk about number 14 tomorrow in class. If you want to try it, see if you're right, that'd be awesome. Otherwise, I will work that out for you, and I will see you guys later.